Alright, you guys, here's some examples similar to part A. We're simplifying and solving with common bases. So back from the beginning of the unit. So the first three problems we're just simplifying. I noticed that all three of these factors have the same base. So that means I can use my exponent properties right away. So I'm going to add the exponents together since I'm multiplying in between the bases. So I still have a base of 3 because I'm not solving yet, I'm just simplifying. Then I'll add them. So 4 plus a negative 2x is just minus 2x. Minus 2 plus 5x. And then I'm going to combine like terms here. So I have negative 2x plus 5x gives me positive 3x. 4 minus 2 plus 2. And I still have my base of 3. And I'm done because I only have one base left. Part B here, I already have all common bases. They're all base of x. I have some multiplication, addition, and then division. So my multiplication rule, when I'm multiplying between two common bases, I add the exponents. So x to the 12 plus 3 plus division rule says I subtract the exponents. Top exponent minus the bottom. So 9 minus negative 2. Simplify, 12 plus 3 is 15, plus 9 minus negative 2 is 11. Now, this is as far as I can go here, because I am adding. So when you're adding between common bases, the exponents would have to be the same. These are not like terms, so I can't do anything else here. If this were multiplication, it'd be different. Okay, but this is as far as I can go. And then our last problem here, when I look at this, I don't have any common bases yet, so I'll actually have to get some common bases. So I see this base of 2. Remember we said that you can only make bigger bases smaller, so I'm not going to do anything with this base of 2, but 32 and 16, those stick out to me. So here I have a fraction. Remember we've said before that if you have a fraction base, you'll use a negative exponent. So I can guess and check a little bit in my calculator. Let's say like 2 to the 3rd, no. 2 to the 5th, okay, 2 to the 5th is 32, the whole number, but I want a fraction base, so I'm going to use the negative exponent. So when I rewrite that, I'll write it in parentheses, 2 to the negative 5th, and then I bring my x plus 2 with. I still have the first term here, 2 to the negative 3x times this. And then 16 I want to rewrite with a base of 2 as well. Let's see, 2 to the 4th, that works. So I'll do 2 to the 4th power in parentheses. And then bring your exponent of x with as well. Now to keep going here, I need to get rid of the parentheses, so I will distribute the exponents. So I have 2 to the negative 3x. Times 2, negative 5 times x is negative 5x. Negative 5 times 2, negative 10. 4 times x, 4x. Now I have all common bases. It's the same problem we did to start. So I'll just add all my exponents together. Basically, I'm just going to be combining all the like terms here, keeping a base of 2. So negative 3x minus 5x plus 4x. Negative 3 minus 5 plus 4, leaving me with negative 4x, and then minus 10 is the only constant, and I'm done. Last thing here are a couple of problems where I'm actually solving with common bases. So the first one, I already have the same base, so these are the ones we like because there's an equal sign. Notice no equal sign in these first three. If I have an equal sign here and I have the same base, then I am allowed to cross off the bases and just deal with the exponents. 2x plus 7 equals 6x minus 5. And now I'm just solving a linear equation. You have a lot of steps you could take to solve this one. I like things to stay positive, so I'm going to subtract 2x from both sides. So move the x terms together. These cancel. 7 equals 6 minus 2. It's 4x minus 5. Now I'll move the constants together. So plus 5 plus 5. 12 equals 4x, these cancel. Divide by 4, 3 equals x. I'm done. The second one here, I don't have the same bases, so I'm going to need to change my bases. Again, I can only make bigger bases smaller. So I might say, well, maybe I can use a base of 9 to get 243. So let's see if that works. 9 to the second, 81. 9 to the third. Oh, that's already too big, so I'm going to actually have to change both bases. So I know I can make this base smaller right away. 3 squared. 2k minus 1. That one's easy. Now I have to see, well, can I raise 3 to a power and get 243? So 3 to the, let's start 3 to the third, no. 3 to the fourth, no. 3 to the fifth, yes. So 3 to the fifth works. So 3 to the fifth power in parentheses, raised to the k plus 2, and I still have my equal sign. Now I cannot cross off my bases yet. I'm going to distribute to get rid of the parentheses. 3 to the 5k plus 10 equals 3 to the 4k minus 2. 2 times negative 1. Now I cross off the bases and I'm solving a linear equation. Subtract 4k. 5 minus 4 leaves me with 1k. Subtract 10. K equals negative 12. And I'm done.